What'd you get?
G.
G.
Yes.
What do you guys think?
Yeah.
Thinks it's G. So we're really given 3x squared minus 2y, and we want to know what's that value. We'll plug in 3 for x and plug in 5 for y. Do that in your calculator. 3 times 3 squared minus 2 times 5. That's going to be 27 minus 10, which is 17 for the first one. And then do the same here for the second one. So I'm going to plug in 3 for x, and I'm going to plug in 5 for y. That's going to give me 2 times 3 squared minus 3 times 5. That would be 18 minus 15, which is 3. And then we want to know how much does this first one exceed the value of the second one. We can find that by subtracting. 17 minus 3, which is 14. Very good. Today's lesson is going to be kind of short. This is really just an introduction into imaginary numbers.
What
And
about our ICT question?
Oh, yeah, I forgot the ACT question. That's a great point. Let me do that first. So we talked a little bit about imaginary numbers on Wednesday. Thank you. The imaginary number happens when you take the square root of a negative number. Because you can't take the square root of a negative. And we talked about why that was. It's impossible in the real numbers. But it's not impossible in the imaginary numbers.
Yeah, it'd be like something square root equals I or something like that.
So here's what they give us as kind of a rundown. In earlier grades, you learned that to do certain arithmetic problems. Did y'all know that's arithmetic? Let's do another teaching example. Y'all know this word?
No.
Arithmetic.
Is this arithmetic or arithmetic?
Arithmetic.
Arithmetic.
It's both.
What?
It depends. Let's turn it to English. It depends on what part of speech it is for which word you use. If it's an adjective, it's arithmetic.
So it's arithmetic.
This should be arithmetic. It should be. Because it tells what kind of problems. So this would be arithmetic problems. If it is used as a noun, it's arithmetic. Because you guys do arithmetic.
Are you an English teacher?
I can be. My highest ACT score was in English. What? Huh?
And you're a math teacher?
What? In earlier grades, you learned to do certain arithmetic problems, such as 1 minus 2 equals negative 1. Or 5 minus 10 equals negative 5. So when you first learned about negative answers, you had to extend your knowledge of the natural numbers to include negative numbers. That's why in 7th grade you had to learn about integer addition, subtraction, multiplication, and division. Because before 7th grade, you would never get a negative answer. Because you thought negative numbers weren't even real. Right? I mean, it didn't even make sense to you. Well, negative numbers made it possible for all subtraction problems to have a meaningful answer. So this is the same time in your learning now that you're learning about imaginary numbers. Imaginary numbers are not new. Imaginary numbers have always been around. You just haven't been taught them before because you weren't ready mentally for that kind of idea. So if I had to solve an equation like x squared equals negative 1, we had to extend our real numbers to also include imaginary numbers. Since the square of all real numbers is positive. That's what that says there. Greater than or equal to 0. You can define the imaginary unit I to be the square root of negative 1. So we let I be equal to the square root of negative 1. Right? I is the square root of negative 1. Now what happens if I square both sides? So what if I squared I? What would that become? That would be I squared. Right? And what happens if I square the square root of negative 1? What happens when you square root a square? Those cancel. Right? Just like when we took the square root of x squared. That cancels. Well, if you square a square root, those cancel, and you're left with -1. So you're getting some building blocks for the imaginary numbers that you will work with next year. So I is equal to the square root of -1, and we said if we square both sides, that means I squared equals -1. This is the required standard I have to teach you in Algebra 1. Okay? That's the only thing with imaginary numbers that you're supposed to know leaving this year. Is that I squared is equal to -1. Okay?
I'm kind of confused.
How I got from here to here?
I mean, if you square that, wouldn't that just...
If I square this, it's I squared.
Oh, I'm thinking of square root.
Yes, you got another difference. Squaring it is raising it to the second power. So if I raise this side to the second power, it's I squared. What happens if I raise this side to the second power? Well, I'm square rooting and I'm squaring. Those cancel out, which leaves me with I squared is -1. There's actually a pattern if you keep raising this to the next power and the next power, but we're not going to go into that this year. You'll do that next year. Okay?
Miss Ferguson?
Yeah. Well, in Algebra 2. Okay, so if I look here, how can you write each square root in terms of the imaginary unit I? So now we're taking the square root of -16. So what number times itself is -16? Well, 4 times 4 is 16, not -16. And -4 times -4 is +16. So whenever I have a negative whole number under the radical, under the square root, I can't take the square root of a negative in the real numbers. So I have to do it in the imaginary numbers. So here's what we're going to do. You know how we would rewrite? If I had the square root of 8, I would rewrite 8 as 4 times 2. Well, now the square root of -16, I'm going to rewrite that as -1 times 16. We're always going to rewrite it as the square root of -1 because we know what the square root of -1 is. That's what we just learned. What is the square root of -1? It's I. It's the imaginary unit. The square root of -1 is I. It's the imaginary number. And now, do we know the square root of 16? It's 4. So the answer here would be 4I.
Wait, would it not be I4? Because you would go in order? No.
You know how we used to write stuff like you could do x times 3?
Yeah.
How do we answer x times 3?
3x.
Because we put the coefficient in front of the variable. We treat this I kind of like we treat variables. We want it to go at the end. Okay? Now, anybody else have a question on this process? I would have a question if I were you. I know exactly what I would ask. Yes, Tay.
Why is it, like, always negative? Who's talking over me?
Go back.
No, Tay, I don't think
That's the voices in your head. What do you mean it's always negative?
Like, why is it always, like, is it always going to be -1 times the
Yes.
actual...
Yes, because we have learned that I is the square root of -1. Just like you learned 4 is the square root of 16, you learned that 9 is the square root of 3. This is something new that you're going to have to know. That I is the square root of -1.
There'll be other numbers besides that.
It can be.
So like what if it's +3 plus square root of 3? How do you do that?
what happens when we get into like.
We're not doing anything that hard to. This is like this is the very beginning.
So what will we do?
Now the reason we don't do plus or minus is because we didn't create this square root. Did we choose to take a square root of -16?
No.
We
No,
tried
that
to do it.
problem That problem was already given to me. So when you're given the square root already, this is what's called the principal square root. It means we only care about the positive square root. If they wanted you to do both of them, they would have put plus or minus out front.
Will there ever be one like that? A plus or minus?
Yes, there can be. You should have already done some of that in 8th grade. Whether you did or didn't, I don't know. But if they have the square root on the page already and they don't have a plus or minus in front of it, then you only want the positive. They can also put a square root with only the negative out front. Then it would only be the negative answer. Or they'd have to put plus or minus if they wanted both. Oh, I did not mean to have that part in there. This is all it should be. Take the square root of -3. So because I have a monomial, I have one term underneath the radical, I can rewrite the square root of -3 to be the square root of -1 times 3. What is the square root of -1? What's the square root of 3? It's not a perfect square. Can I rewrite it as a perfect square times a whole number? No, right? It's too small. So the answer here would be I radical 3. That's the way I would write that.
But why'd you put the I first?
Because you go outside the radical.
Because the I is outside the radical. So this is one of those where it's all about the order of stuff is just weird. You could put radical 3I. You'd have to make sure the I was outside. This is one, there is not one that's definitely more accepted than the other. For me, I always put my radicals after. That's just the way I do
I
it.
think it's the top
Because
it's easier to see that it's not inside the radical.
that's the way I think about it too. But later on, when you start doing complex numbers, they'll want you to write it this way. But again, I think either one of these are correct. Let me see what the book did here. The book put the answer as radical 3I. So the book put this as the answer.
Either one would count both.
Yes, they both are correct. Like I said, I guess I got stuck doing it this way. I probably need to start writing it like this. This is probably the more correct way.
That looks weird. Number first. Like
Okay, that's fine.
4.
That's fine. To make sure I get a single x, is we need to eliminate one of the terms that has an x in it. So we could subtract by 2x on both sides. 2x minus 2x is 0. We're left with 3 equals 3 minus 2x is x. Bring down the minus 4. Now I need to add 4 to both sides. So x equals 7. Don't put it on the board. What'd you get? J, 42. And how did you get J?
Divided a lot.
You did a lot?
Divided by 7 at first.
Yeah.
Why?
Oh, 21 is also multiple of 42. And I'm like, oh, wait. And I just,
So this is one, if I got this problem on the ACT, I would definitely take advantage of the multiple choice. Right? Because there's only 5 options for what's the greatest common factor. So which one would I try first?
Big number.
I would try the biggest one first. Right? Because I know 2 works for all of those. But there's no point in trying to. I would just try 42 for all of them. So 42 divided by 42 is 1. 126 divided by 42 is 3. 210 divided by 42 is 5. So since the biggest number on the page worked for all 3, then it must be the GCF. If 42 didn't work, what would you try next? 21. If it's asked for the GCF in a multiple choice, Start with the biggest one and work your way back. Here would be my process. I'll just show you how I would do this. It would be very quick. How much money did they make the first year? I don't know. Let's say what they made the first year. Let's call that value X dollars. They made X million dollars the first year. The second year, how much money did they make?
3.
3 more than the first year. So how could I write that? X plus 3. The third year, how much money did they make?
2 times the second.
Twice the second year, which means 2 times X plus 3. No, double. Means you multiply it by 2. No, squaring it is not twice as much. Twice as much is multiplying by 2. So the third year, they made 2 times X plus 3 amount of dollars. I also know what? The third year, they made $38 million. So this must be the same as 38 million. So what I can say is 2 times X plus 3 has to be equal to 38 million.
Wow, so what do we do now?
Solve for X. You have an equation with one X and you solve for it. So if I had to solve this, you could distribute. I wouldn't distribute. I would divide by 2. So this cancels. So now I've got X plus 3 equals 38. Nope, that's wrong. 38 divided by 2 is 19, right? And now X is being added by 3, so I subtract by 3.
I told you it was 8.
So that tells me X is equal to 16. So it's 16 million.